something kind of new. So write down the important information from the fear of negative evaluation study results on page 20. Was that down the bottom of here? Yep, here it was, because here was the fear of negative evaluation study. And we oh yeah, this is the data set. Okay, so this is the data set, and these are the results. So we got a minimum of 8, a lower quartile of 12, a median of 16, 20, and 39. So we've got to write those babies down, and we're probably going to have to do a box list of plots. What's my minimum again? 8. What's my max? 39. Oh yeah, that's right. There was a freak. There was a bit of an outlier, wasn't there? Yeah. What was my lower quartile?
12.
What was my median?
16.
And what was my
20.
26. So what kind of, remember we kind of discussed why 39 could possibly be an outlier. What other data kind of insinuated that 39 is a bit of a freakish value?
The median?
Yeah, the median. It's so far from the median. The minimum is pretty close to the median. It's not too that far from 8. It's not that far from 16. And 39 is way off the median, and way off the upper quartile too. So maybe an indication that 39 could have been a outlier. Does this person have a high fear of negative evaluation or a low fear? High fear, yes, because it was meant to be this higher the number, the higher the fear of negative evaluation. Okay, so draw up a number line and mark in the scale that fits your data. So actually I kind of put in that bit for you because that's kind of painful to do. And then we just need to, our scale has to go from what number to what number roughly?
8 to 39.
Yeah, 8 to 39. So sometimes I go 1 below, 1 up. Like maybe I'll go 5 to 40 or something like that. Because we don't have that much space. So you decide your own scale. Okay. Start at 0. Let's see if I can stretch that.
Can we open 2s?
Yeah, it could go up in 2s maybe. Will it fit? How many things will it?
Yeah.
It will? Okay, starting at 8?
Yeah, 8. 8. Then you start with 2.
Oh yeah, if it fits. Yeah, if it fits, let's do that. Oh, brilliant. It does fit. Yeah, so we could have started at 2 or at 0, it doesn't matter.
Did I miss a number?
I might have. They really like you to put the what's going on as in, like, you know, some kind of axis label. So you can call it what you like. I might call it the fear of negative evaluation, FME study result. So that's my label. I like to draw my box first. Some people like to draw their whiskers first. Whatever you prefer. So the box is the median, the lower quartile, and the upper quartile. So 8. No, what am I saying? That's a minimum. 16, 12, 20. And they're kind of the thicker lines. And don't draw them on the scale. Draw them somewhere above. Doesn't matter too much how high above, so long as it's above the scale. So my median, straight line. And it's going to be a thicker line because it's a box. 12 and 20. And the length of the line for the lower quartile has to be the same length, kind of. And make sure they're kind of lined up. And then I kind of, this is my favourite way, I just like to do the box first. I think it's kind of fun. Some people like to do all the lines. And then the whiskers are easy. And the whiskers, you draw them like a thinner line, so the kind of in the centre and not as high. They're little outliers, kind of, or, you know, outer regions. So 8 and 39. So I go to 8. I'll try to do something not quite right. What's not quite right about the way I drew my whisker? It's too high, yeah. It should be kind of a bit narrower. And what's a bit weird about the way I do it now? Too low. Too low, yeah. It should be in the middle. You generally see them drawn. So kind of
You just do a dot?
yeah, some people do dots. That's a good point. Yeah, some people do dots. I'm just in the habit of doing it that way. So the dots are generally accepted too. And 39 is halfway between 38 and 40. And should ideally be a straight line. I'm doing it freehand, which looks dodgy. And yeah, make sure you've got a little scale, like you've labelled some kind of scale, you put a title as well. Common errors, people will draw their box and whisker plot actually over the scale, but don't do it over the scale. They like it to be sitting above the scale somewhere. If we had two separate groups, and they, like say maybe this is one group of people that lived in Canada, another group of people that lived in the UK, you could do parallel box and whisker plots. So if the results went from 0 to 40 for the other group, you could above have the results for the other group, and you could do a comparison then. You can visually compare their box and whisker plot to their box and whisker plot, and you would just have to label which one is which. What percentage of the data lies within this box? You remember thinking of
50%.
yeah, 50%, yeah, because you're right, 25 and 25. So interquartile, so by quartiles we mean like 25% of the data is within here from 8 to 12. 25% of the people, their results were from 12 to 16. The next 25% up were from here to here, and the last the top scores were 25% of scores were between 20 and 39. So that's why they're called quartiles. What do we call this value here? Upper quartile, good, and this one? Lower quartile, and this one? And what value is represented by the length of the box? Yeah, the inter something. Yeah, that's right. So the length of the box tells you the interquartile range, because Q3 minus Q1 gives you the length of that box. What length do we call from the min to the max? That length, the range, yep. So it's a way of visually showing you how the range compares with the interquartile range and how the median kind of sits. Would you say the median's right in the center of the values?
No.
Nah.
I would say the upper quartile.
Yeah, a bit more so, isn't it? Yeah. So we would describe this as skewed because it's not a symmetrical box plot. Symmetrical box plot is called a symmetrical box plot. But this one, there's more of a skew going on. So it's skewed a bit to the left. And over the page, we talk a bit more about, is it positively skewed or do we call it negatively skewed? Yeah, so that's what we did. With vertical lines, we marked in the min, the max, the median, join the lower and upper quartiles forming the box. Yeah, so that's how you draw a box and whisker plot. It's pretty fun. Quite often you'll be given a box and whisker plot and asked to interpret it. Like, what's its median? Because you don't label that this is the median. You don't label that's lower quartile, the upper quartile. It's just implied. Yeah, if you want to, because it's for your notes, it's okay if you do for your own reference. But generally when they present it to you in an exam, they won't be labelled at all. You just have to know which one's which. Okay, let's move on and do some interpretations. So as I said, the one that we had was skewed. It wasn't symmetrical. It's possible to have a box and whisker plot that's beautifully symmetrical like this, in which case we call that a symmetrical box and whisker plot. So say if the data kind of made this kind of nice symmetrical bell curve, we'd probably get one like that. But you can get ones which are skewed. So, yeah, skewed is what they call it. So one that's kind of shoved to the left, they call that positively skewed, which some people find counterintuitive, because some people think positively skewed means it would be to the right. but positively skewed means that the values are more to the left, kind of like our box and whisker plot on the previous page. Therefore, if it's negatively skewed, it's more to the right. So this one is negatively skewed. So maybe make a note of that, just because it's not very clear in the writing. This one's negatively skewed, if it's kind of shoved a bit to the right. And the other one is positively skewed. So there's a positively skewed one, a negatively skewed one, and the top one is symmetrical. And the one at the very top, the box and whisker plot at the top, is a nice symmetrical one. Symmetrical around the median. That's very interesting. Just something extra. That sometimes if people do box and whisker plots in their internal assessment, they can comment on whether their box and whisker plot is skewed. So if this was our IA and we did a study and did a box and whisker plot, we would say this is, what was it again? Was it positively skewed? So it just gives you a way of interpreting it, showing that it's not symmetrical. Like the data is more concentrated to the left of the number line rather than the right. Okay, so that's that. Oh, isn't that cute? Box and beard plot. Oh, yep, I remember them. So what's really common, drawing the box and whisker plot takes a while. So some ways examiners can just throw this at you and kind of get you to do it quickly is they give you the box and whisker plot and expect you to interpret it. Would you say this one, it's not exactly symmetrical, would you say it's positively or negatively skewed, this one? Yeah, negatively, it's to the right, yep. So Mr. Foreman grades on a curve in which the top 25% of the test scores earn A's, the middle 50% earn C's, and the bottom 25% earn F's. So according to this teacher, you can only get A's, C's, or F's. The box and whisker plot shows the distribution of scores in the last test. So what's the range of scores for the people who earn C? It would be from? Close? The C's?
75 to 55. 65 to 80.
Yeah, 65 to 80, yep. Because the middle 50% earn C's.
The range of
Oh yeah, so you could calculate it, yeah, exactly.
the middle
Like
50% from 65.
so you could say from 65 to 80, or you could say 80 minus 65. So 80 minus 65, as you said, is 15. So it's okay if you did that, the green version or the blue version in that case. Because they didn't say specifically what is the interquartile range, in which case you would have to do the blue. But they just said, what is the range of scores? So it's kind of something a bit more vague. Find the mean score. Hint, you may need to make a table of midpoints. So this is where it can be tricky, because remember, so you could consider, we don't know how many pieces of data there are, but we know that 25% are here, 25% are here, and 25% are here, and 25% are here. So we can write these into categories. What would be the midpoint? Yeah, how did you get that?
Just half it between 55 and 65. Or just add 65 and 55 divided by.
Yeah, exactly, if you're not sure. So if it's one you can't really see the midpoint really easily, add the two outer regions together, 55 and 65, and divide by 2. In which case you get 120. Yep, and then divide by 2. So the midpoint of the first category is 60. And you can think of their frequency as being, if you want, 25%. Because it's just a relative frequency, really, isn't it? Or if you wanted to write 0.25, that's okay too. Some people
Why
do.
you writing 25%?
Because 25% of the data. So we don't know how many people there were in total. If we did, we could work out what's 25% of the total. But we don't know the total amount of people. So we'll just say, maybe let's assume there was about 100. So relatively, there would have been 25 in that one. And then what would be the midpoint of the next quarter? 70. Yeah, 70, yep, 65 plus 70, multiply that, 70, and again that's just 25%. It's equal amounts in each. I've seen this kind of question on some exams before in the past and people have been a bit thrown by it, so that's why I thought I'll put 2 questions like this in our notes. Midpoint of 75 and 80?
77 plus 5.
Yeah, minus 25, and the midpoint of the last?
2.5.
Yeah. 32.5 and 25. And remember, it's kind of like going back to finding the mean. To find the mean by hand, you could put this into L1 and L2 in the calculator, and then just find the mean, do that second stat calc, sorry, 1 bar stats. If you were to do it by hand, what column would you need in the final column?
Midpoint times frequency.
Yeah, exactly. FX. Some people think it's
That's
the
how you
midpoint.
do the mean.
Yeah, how you do it by hand. Midpoint being X, the frequency being F. So FX would be the frequency times the midpoint. We work out our little totals.
25 or 0.035.
Yeah, I use 25, but yeah, you can use 0.25. You'll get the same result in the end. If you use 0.25, your total frequency would be 1 instead. But if you use 25, your total frequency is 100. And you have to work out your total FX.
Okay, so no matter what example we use, we can only use 25 or 0.25.
Yeah, exactly. Well, that's the fastest thing to do because they're in quarters. So they're split into quarters. And then you work out those things. Sorry, what's my first one? 60 times 25.
And what we do 60, you can't do 60 times 0.25?
Yeah, you can do that instead. In which case, your total frequency would be 1 instead.
Okay.
So in a way, like,
Oh, 60 times 25 is 1/500.
and 70 times
Oh,
25.
sorry.
70 times 25.
I can air you too. I don't.
75 times 25.
Are we supposed to answer?
Yeah. I don't have a calculator.
1937.5.
1937.5. And what would be my total FX? Or if you did it with 0.25, 7250. Cool. So the advantage of having done the 0.25 version is if you kind of, your total would automatically be your answer because then you would just be dividing by 1. But it's no different if you do 25. Sometimes people find this easier because they can visualize, oh, if there was 100 people, that makes sense. So yeah, how do I get the mean then?
I thought that 250 divided by 100.
Yeah. Like 100 equals?
That's only 2.5.
Yeah. And then it's good to critically analyze your answer. 72.5, is that even possible, or is that like an insane answer according to our data? Yeah, 72.5, it's a normal sounding number. So it's not like it's 7,000 or anything. So it could be within here. So it's got the mean, obviously the mean and the median can be different numbers. Okay, so good. So the box and whisker plot, next one, below shows the starting salaries for graduates at a small college. What is the interquartile range of the starting salaries? Q3 minus Q1. Goes down to Q3. So it's not a very good scale on this one. 25,000 minus 25,000. What is our interquartile range? 20,000, yeah. Do they have units or anything? Because I said US dollars. I said dollars, yeah. So imagine I asked you to interpret the interquartile range. What's something that you could say?
It is positively skewed.
Oh yeah, the box and whisker plot, yeah, is slightly positively skewed. Yeah, the box and whisker plot slightly positively skewed. And the interquartile range, you just say that the middle 50% of, you could say the middle 50% of starting salaries were with, like, there was a difference of $20,000 between them. that kind of thing. Nothing really exciting there. But yeah, so it is a slightly positively skewed box and whisker plot too. That's a good point. So a few more little interpretative ones. Mr. Andrews made a box and whisker graph. Notice their scales on the top here. They didn't label it with anything, so they're a bit dodgy. Of the quiz grades in his chemistry class, is his results positively or negatively skewed? Negatively skewed, yeah. Yeah, so let's make a little note of that. Slightly negatively skewed.
Negatively skewed.
Oh, it's kind of symmetric.
It's positively skewed.
It's interesting, isn't it? Because the median's towards this way, but the box is towards that way. So it's a hard one to interpret. So let's just leave this. But it's a tough one. The median's kind of right smack bang in the centre, isn't it?
No.
But the box is slightly. Would you say?
Wait, no, it is.
I don't know. It might be just the way it looks on the board. Yeah, like from here to here, would you say the median's kind of in the middle?
Yeah.
But the box is slightly positively. The box part is slightly positively skewed.
Yeah.
Oh, negatively.
Negatively
yeah,
skewed, right?
So you're right, yeah. I would avoid interpreting that one. Yeah, so if there was one like that, I would probably just make literal comments. Like the median looks like it's right in the centre, but the box is slightly to the right. So I would avoid saying skewed, because it's hard. It's not a really clear one. Some might say slightly symmetrical almost. Yeah? Okay, so Isabella, what is the median quiz grade? How did you get that? You do? Is it yet? 77. Is there any units or anything there?
It doesn't say. It says 77 in terms of grade. So I'm
Okay.
confused about it because it's not
So
like
it's probably percentage.
it's a quiz grade or something.
Yeah, let's put a label on it. He didn't do a label, so it's kind of dodgy. So grade. So let's give him a label and pretend that there was one. Grade for you. Say grade for chemistry quiz if you want. Normally the scale's on the bottom, like so their scale's a bit weird. Find the mean quiz grade. We have to do this all over again. So this is the last one where I get you to find the mean. It's just that it has come up on past exams sometimes, and people do get a bit thrown. How do you find it from the box and whisker plot? You just do the midpoint. So midpoint, frequency, and fx. You can do this one on the calculator if you want. You just need to find the midpoint.
Thank you. Oh dear.
It's tricky to find the midpoint. Can anyone see what the midpoint? Where's it from? 58. You all agree? Oh, it's hard to see. 58 to 70. Yeah. So what would be the midpoint of 58 and 70? 64? So you can either do 0.25 or you can do 25, whatever you prefer. I tend to think of them as whole people, because then I can visualize it, 25 people. And we don't know how many people there were, so let's assume about 100, because we can split these into 25. Midpoint of the next bitty. That's a nice one. 70 up to, what's that, 77? 73.5. So we're going from now next 77 up to 81. What's that?
It'll be 79.
I think so, yeah. Let's see, 77 to 81. It should be a whole number.
So it should be 79.
81.
I'm sorry, I'm reading it wrong. You're probably right. Yeah, sorry about that. Yeah. Yeah, I was wrong. 81.5. I was reading it as 81. That one, but it's 86.
So this is 7, 7,
And then what's that one? Is that 86 up to 91? Another 0.5.
And 96, not 91.
Let's do it again.
It's 91.
Oh, it is not.
It's 91.
It's easy words.
73.5, 81.5.
No, I'm saying that it ends at 96. She said it was
Oh,
at
yeah,
91.
It's a midpoint 91 though.
Yeah.
Okay, thank you, yeah. So if you want, feel free to do this one in the calculator if you want. Practice doing the calc. We go enter in L1, L2, stat edit. don't need to write this down if you remember how to do it, don't worry about it. So that edit L1, L2, and then stack calc. 1 bar stats, because it's just one variable. And then you've got to tell them the X list is L1, and you've got to tell them the frequency is L2. And then from that, hopefully we get a mean. Hopefully, let's get some confirmations.
77.5.
Feel free to try it out. See if you get 77.5%.
Yeah.
Yep, so the key thing was to tell it that the frequency list was L2. That's the most commonly missed aspect. Stat edit, stat calc, all that bizzo. So that's the last one where I asked you to find a mean from a box and whisker. Oh gosh, seriously.
We don't have to.
Do you want to do this one?
No.
It could be practice. It could be practice, all right, yeah.
Say it's
Do you know what to do though? Do you know what I'm asking you to do?
Yes.
what?
Prepare a
Parallel
box plot for the data set to use it to compare the two drugs for speed and
Yeah, we should definitely do this one.
So parallel box plot just means that there would be one box plot, and then for the other set of results it would be on the same scale. Like you don't draw up a new scale. So you just do one and then you do another one.
Those parallels just mean you draw them next to each other and then compare.
Yeah. Yeah, you just draw them one on top of the other, yeah, exactly.
For what? Is he saying they did all this time?
Do you have to talk about them?
And compare, use it to compare the two drugs for speed and reliability.
So yes.
Yeah. So
Please don't do this now.
How do we know?
Just draw them next to each other and talk about their differences.
oh, how reliable it is. Let's see. So what was it? It was to do with the drug test.
You wanted to be quick though, so everyone had a shorter time.
So let's see, what was the context?
The drug ones around about the same, but a little bit faster.
We haven't done anything.
Is trialing a new anesthetic drug and has collected data on how long the new and old drugs take before the patient becomes unconscious.
I hate that.
They wish to know which drug acts faster and which is more reliable. Okay, yep. So which ones act faster, I guess, have the lower times. Would you agree that the ones that act faster would have the lower times overall?
Yeah.
Would you agree more reliable just means that there's less of a range of results?
Yes.
So if their range and their interquartile range are narrower, then they might be more reliable. More consistent is what we also call those ones, more consistent, because their range and their interquartile range is narrower. Okay, let's just, if you want, like, we can go back to that as practice or something. Okay, move on to cumulative frequency graphs and stem and leaf diagrams, which you would have learnt both of these in CIE. Was stem and leaf in CIE?
Yeah.
It was, yeah, okay, good. What is cumulative frequency? It's a running something
A
of the...
running tally of the frequency column.
Yeah, exactly. Running tally or running total, both are okay, of the frequency column.
Oh,
So running total. Yeah, tally, same thing. Yeah, running tally, running total of the frequency column. That's what we mean by cumulative frequency.
Wait, what the heck?
So, starts with the same number, then 0 plus 5, 6, yeah. I think I made a mistake. And then your total frequency in the end should be the same as the total frequency of the frequency column. So if you add up these standardizations, it should be the same. So that last 150 should be the same as the 950. You might just be asked to interpret a cumulative frequency table. So how many athletes weigh less than 60 kilograms?
Less than 60 kilograms?
Yeah, you're right, 0. That's only the first category.
I don't know.
How many weigh less than 65?
5.
5, yep. How many weigh less than 70? 16, yeah. So it just means you don't have to add it up, it's already in the column for you.
Why do we not do it?
I just think to celebrate this again, it's gone off again. I'm able to scroll with everything. How many weigh less than 65? Sorry, how many weigh less than 75? How many weigh less than 80? 42. How many weigh less than 85? And then how many weigh less than 90?
High five, sis.
50?
Sure.
All of them? Okay. That's a bit of a boring interpretation. Not the most exciting one. Oh, okay. I probably need to make some up for you then. Okay. That's true.
No, Mr. Mooney.
What? Just the numbers. Okay, so drawing a cumulative frequency curve. So what's interesting is we haven't even given you any frequencies to begin with. Where did this come from?
Oh no, you're not that funny.
Okay, I'll just make some up. I'll do some over here. Frequency.
Mr. Mooney.
It's a bit messed up, isn't it? It looks tacky. How many?
You didn't even cut mine off properly.
I'm just making some numbers for you.
People
There you go. Just made up some nice, easy numbers.
But the cumulative frequency on the graph goes up to 120.
Oh no! What if I just make them this? Does that work?
I think that goes to something.
We need something that adds up to 120, don't we? Or just slightly
You just
less.
randomly picked up numbers.
What is the less? What does that add up to?
180.
180? I know!
Just make something like 40.
What do you want to add up to? Okay, no worries.
No, 120. What do you want? Oh, 220?
Just do like, yeah,
Bruh.
20 and then
Exactly,
like
erase it.
like
Oh no, don't erase it.
Number 15.
For the first one.
Wait, let me add this up.
Yeah, what are we up to so far? And then we'll see how many.
Yeah, this is
I think we should do a bigger number next. 35.
No, it's not.
35, 56. That's 35. No.
That was
100? 23, okay.
That's a small number. Well, that's 120.
Okay, good. The great thing is it adds up to 120. That's what we want.
Okay.
So
Someone says something
now we're going to
about
cumulative frequency.
Nice.
The next one. What would be our next one?
47.
Yeah. What would be our next one?
Wait, what do you do?
Oh no.
Oh, you just add them up together.
Yeah, the running total.
47 plus 15.
62.
I don't know.
Plus 35.
97.
97.
120.
Oh, thank goodness. Okay, 120. The mine was pretty frequent. I'm pretty sure, I should double check, but I'm pretty sure if it's like CAE, I can't remember, normally it is the same as CAE. CAE supposed to do the same as IB. Okay, so back to here. So remember in CAE, you always graph the upper limit was the coordinate, x coordinate, not the bottom one. The upper limit was the, yeah. So we need to, so that's your x coordinate. So that's your x coordinate, and the cumulative frequency is your y coordinate. Which makes it easier, so it's the same thing for us. Some courses graph the lower bound, but I don't, most of them that I've seen graph the upper, including CA. So now we've got to do all these little points, and then make a nice smooth curve through it. 10 and 20, I've got to scroll up. 20. What's that next one? 20 and 40.
Good dog. I don't want to start
30 and 47. 37, 40, 60. Probably haven't done graph for a while. 40, 62. 50, you do a curve, so a nice little curve through it all. And then 60 goes up to 120. So sometimes you might find, it varies, sometimes you find nice little S-curves. Sometimes they form little S-curves, sometimes they form kind of more like just curves. I'll just zoom out a bit so you can see it. You start at 0, so at the 0, 0, because that makes sense, like, you know, 0's down here.
20 and 30.
Yeah, so this one's not, oh, it's a bit messy.
30 and 47.
So it's kind of like a little curve. You kind of look at it and try to decide what kind of curve is it, like it kind of curves down and then up. Sometimes they're like these little S curves instead. And sometimes they're just curves, these cumulative frequencies. So it's not a line of best fit, it's more like a curve. So try to look at it and see how do I envisage doing this little curve? And then you kind of just give it a good old go. So this one's kind of got a bit of a bend going on here. Yeah. So really this one should have gone through more so through that red. Yeah, so you connect the dots with a smooth curve, but one not very nice.
Oh, so don't use the ruler. I can act a little bit now.
Yeah, well, they call them cumulative frequency curves. Yeah, mine doesn't look that nice.
Mine looks weird.
Yeah, sometimes they can look a bit weird. We had numbers that were very top heavy, and that's why kind of elements come out a bit like this. But that's okay, it's possible. It's not like this.
I don't like this graph.
Like
Why
the
is that
wrong
fake?
ones are there.
That was funny.
Mm-hmm.
The wrong lines
I
are
kind of
there.
like that. That's a bit nicer.
It's like sometimes.
Basically, don't do a line of best fit.
It's like every 4 and every 2.
Yeah.
It should be 10. Every 10 should be thicker, but now it's got like.
And the boxes are not the same size.
Yeah. So make it a nice curve, and what was I going to say with that? Can't remember. But yeah, make sure it goes through the points. Like you don't miss points. It's not like a line of best fit. How you can skip some points, and it just gives you an overall thing. It should go through the points. But this is a bit of a dodgy one. So now we need to use our graph. Quite often we're using the graphs to find things. Use your graph to find an estimate for the median amount of money spent in the shop by these people. So what was our total frequency?
110.
Yep. So to find the median, does anyone remember from CIE? Go half. Yep, that's right. There's a lot of dots going on. Yes. So go down halfway, as Katie said, to 60. Half the total is 60. Then you read across and down, and that's your median.
It's not.
So sometimes they make the total go beyond. It has to be wherever the graph finishes. See our graph finishes at 120? So even if our scale went up to 130, just read it down from where the graph finishes.
Oh yeah.
So to find the median, we go across to 60, and then we do these dots.
So you have the total?
Yeah, exactly. Half the total, and then read across and down. And these dots are considered like you're working out. So use a ruler. Don't do what I'm doing. That looks pretty awful. So you should use a ruler to do this dot.
No, it's not.
Yes, it is. She knows it is. Now she just needs stuff.
Yeah, and they'll be slightly off. So they allow a range within a range. Yeah. So and see these dots. They're how you get your method mark, because you're showing your examiner how you got your answer. It's all right. Yeah. So long as it matches your graph. So everyone's graph will be slightly different because of the way they drew their curve between these 2 points. I got my one. I would say it was about 38.5.
Okay. Someone and your captain. Give me a cookie.
Yeah, 38's fine. 39, that kind of thing. Yeah, 39's fine. You just write whatever matches your curve. So it just has to match your curve. And like putting the dots helps the examiner to see where you got your answer from. So that's why you should show that. So use a graph to find the 90th percentile. So the median is what we call the 50th percentile. So that's a little clue. The median was the 50th percentile. quartile, which meant that because we went halfway down from the total and read across and down. The lower quartile, if we were asked to find the lower quartile, it would have been the 25th percentile, because we would have gone down to a quarter of the total and read across and down. If it was the upper quartile, it would have been the 75th percentile, because we would have gone like 3/4 of the way up and across and down.
So how do you find the 90th? Like,
Yeah.
if you like 120
Wait, I missed it. Can you say that again?
divided by 90, no, it doesn't make
Close?
sense.
Oh,
Times,
no.
120 divided by 0.9.
But yeah, so the lower the median is the 50th percentile, so
The
it's halfway
lower
down.
quartile is 25th percentile.
Yeah, and the upper quartile is the 75th percentile.
Yeah.
So where would be the 90th percentile? How would we find, where would we read from? Yeah, find 90% of the total. So 90% of 120 is what we would find.
How do you put it down?
Yeah. Oh, how to find 90%? Yeah, 90 over 1 times 120 over 1.
What did you say?
90 over 100, sorry, times 120 over 1 is how you would do it. I tend to work out what's 10% and then times it by 9.
Yeah.
That would be easier, yeah. Yeah, that's easier, isn't it? Yeah.
12 times.
Yeah, 10% of 120 is 12 times it by 9. 90 percentile is read from.
No.
I got
No.
that.
108, right?
90th percentile. It can't be 55.
No, I think she read to 108 and then read down. And she goes down.
Or was it 108? Yeah. And then you read across and down.
Pick a fight with me.
Yeah, so you go up to 108 and you read across and down from 108. So using a ruler is a really good idea. Boy, cannot scroll on them.
I got 55.
Yeah, I got about 55. So whatever matches your graph, they're always slightly off because of the way the curves. Honestly. Read across and down. And then we read across and down, and I got 55, whatever you got is fine. Is there any units for this one?
Dollars.
They normally allow, maybe plus or minus 1. So if that was meant to be the correct answer, they probably would have allowed 54 to 56. But if your graph was drawn slightly wonky, they have to look up at your graph and follow through. So if you had a bit of a weird looking graph that was slightly off, you could still get full marks for this so long as it matched your graph. So doing the ... are really good because it leads the examiner to see where you got your answer from. And shows that you kind of knew what you were talking about. Yes, Dave? See. But there was no units, was there? No, okay, yeah.
Actually,
Pounds, okay. Let's do that. Let's be defensive and we don't allow any reasons to take any marks off. Pounds. So whatever your answer is, it's fine, matches your graph.
your unhappy face, Bella.
Here's another one. So what's even better is when they've drawn the graph for you. That's so helpful. And then you just have to interpret the thing. So see, quite often they're kind of these S curves. They look like a snake, don't they, coming out of a toilet bowl.
What did you say?
It looks like a snake coming out of a toilet bowl. Quite often these cumulative frequency curves. Here. It's coming out of it. It's hissing at you.
Why couldn't you just say an S?
I think it's a uniquely Australian perspective.
Yeah.
Yeah, there you go. That's a bit more happy. That was more of an Australian take. Okay, so the cumulative frequency graph shows the speed. Here's the units, kilometers per hour, of 80 cars passing the speed camera. So what was our total frequency? 80, yep. So this is nice because the total is at the top. Sometimes they might have gone to 100, but remember we consider the total to be 80. So 80 is our total. I sometimes mark that in the total because sometimes they write the scale above the total. And it's annoying then. People read the wrong thing. What do we ask to do? Oh, Nick. Okay, this is classic. This is, IB seem to like this, where they want you to fill in from the cumulative frequency, they want you to fill in the frequencies. So that's an exchange, not the cumulative frequency, but the frequency.
Oh, so how are we gonna wait? We have to think about this logically.
Exactly, yeah. So from 0 to 50, what was the change in Y values?
10.
10, yeah. So the first one's nice and easy because it's from 0.
So it means that the next one is like from 50 to 70, 14 or something like 17.
20.
How do you get 20?
Because it's still 29.
It's 17.
And 30 got 10, which is 20.
Oh, yeah, because it's
Why
from
do you
50
say
to 70, yeah.
17?
So from here, because
Because
that's
it
from
may
50
be
to
70.
50
Oh, I
to
just
70,
said 60.
it does go up by 30, yeah. No, it goes up by 20, yeah. So yeah, they don't, yeah, that's if they wanted the cumulative frequency, that would have been easy. We would have just filled in the Y coordinate. But if they want the frequency, it's the difference between the two previous Y coordinates. The 34, that was kind of there. The 34 was put in case anyone was really stuck. They could look at it to see how it was done. 80 to 90. They're probably giving me weird numbers now, are they? They're making it so nice. I can't see it. Oh gosh.
12.
Like, try to find out what's missing.
That's what I did.
Yeah, you could find the cumulative frequency first, yeah, and then you could work back from there. That's also okay. I'm just being lazy. So, is this one from 68 up to 76?
12. Oh, sorry.
65.
64.
64.
Yeah, because it's
65.
12. because it has to add
Oh,
up.
yeah.
64.
Yeah, you're right, 64, yeah, sorry, yeah. 64 up to 76, is it?
It's 12.
Okay, good. Alright, so we're agreed. Oh, and the other one, last one's done, that's great. But yeah, so yeah, you could just work out, like, actually just write down the cumulative frequencies into a table instead and then subtract and work it out that way too. I'm just being fast and lazy. Who's that? What's that? Huh? Oh, that's annoying. Okay, anyway, so you might not have seen this. Owen just said this question's cut off your page because the printer is not printing the bottom of the pages. So it's just asking you find the IQR. So we need, for that, we need the lower quartile and we need the upper quartile. So do it. Find it. The Q3 minus the Q1.
It doesn't say it.
Yeah, so we need to, what's 3/4 of the total? 3/4 of 80?
But 60.
Yeah, so. And then you read down. Oh, such a tall graph though. Painful. Did you get something like 79 for the Q3?
Yes.
Okay, good. For your Q1.
I got 17.
Whatever. It sort of looks like it's halfway across.
Can you go down a bit? Thank you.
Yeah, Q3 minus Q1. Oh yeah, so this little question was missing from the bottom of the page, yeah.
Yes, I got
79.
though.
I got 79 for the Q3. I haven't done the Q1 yet though.
I thought you were just. So once you find it at 60, you can 60 and you try to figure out what it is.
Yeah, so so for the lower quartile, what's a quarter of the total?
20.
Yeah, good. 20, yeah, so read across and down from 20. And notice 20 is kind of like 3 units across from wherever it was. 63, yeah. I would agree. I got 63 as well. They've tried to draw it nicely for you. And so what's our IQR? 16.
16.
So the middle 50, is there, oh, we need units. Let's not let them take any marks off.
16 kilometers per hour.
Kilometers per hour. Yeah, because at the very top of the question, they mention how it's speed in
Do
kilometers.
you have to rewrite the units the same, or can you write like km/h?
Yeah, that's okay. KM/H is also okay. I tend to just write it the way they did it. Yeah, KM/H, if that's your way of doing it, that's fine. This is the physicsy way. Yeah, so notice here you can find interquartile ranges. So the middle 50% of data has got a range of 16 kilometers per hour. It was from 63 to 79. On the next quest page, we've got more. No, we didn't. I must have decided it wasn't worth it. So let's just do those ones only. If I wanted the 30th percentile, no, that's a bad one.
You would do 10, you find 10% each day, and then times by 3.
Yeah, that's true. Yeah, that's a good way. 24. And then you'd read across and down from 24. Yep, that's how you find a percentile. Stem and leaf, fun, fun, fun. We've got like 3 minutes.
Yeah, I say we just call it Christmas already.
Do you want to, or do you want to do a stem and leaf?
No, I think we should call it Christmas.
Okay, all right. I'm fine with that.